In podcast number 10 from chapter 10, we're going to discuss some of the very, very basics of cancer. And in this podcast, we're just going to cover this one slide. All right, now remember, cancer is defined as uncontrolled cell growth. So this title up here in blue, that's our definition of cancer. Now, cancer occurs when those normal regulatory processes like cyclins, internal growth factors, external growth factors, those hormones, of course, and they do not go through an apoptosis process when they're worn out. That will lead to cancer. And a big mass of cancer cells is simply called a tumor. Now, telomeres are often in play with this because cancer cells essentially have the ability to live forever. Because when they divide, their telomeres do not get shorter. They actually can get replaced. And so essentially these telomeres stay the exact same length as they were at the beginning through their whole life. And because their telomeres do not get short, the Hayflick limit doesn't have anything to do with them. Now there is a famous type of cancer cell out there, and it's actually called a HeLa cell. And a HeLa cell, I believe, is a breast cancer cell, and this is one of the main things that are used in cancer research. And the HeLa comes from the name Henrietta Lacks. This woman died, I believe, in the late 50s, early 40s, and without her family's permission, these cells were kept, and they were kept alive, and then distributed out to these various different types of cancer labs. And so these HeLa cells have just been around since 1960, we'll say. So you're getting near 60 years. So the tumors from this lady, Henrietta Lacks, they've been around and alive for 60 years, which pretty much tells you their telomeres do not get shortened, and the Hayflick limit doesn't apply to them. There recently was, I believe, published late last year, maybe 2009, a book on the Henrietta Lacks story. I think the book is called The Henrietta Lacks Story, and it was on the New York Times bestseller list. Now, the P53 gene, which we've already learned about, let's go back this one. The P53 gene, if you can remember, is called the guardian of the genome. All right, so I'm just going to write that off here again. I'm just going to write guardian this time since we've already went over this. Now, the P53 is the major spell checker when it comes to DNA replication, because the reason that cancer comes about is that you have a lot of mutations. Now remember, a mutation is any change to the DNA sequence. So once you have enough of these mutations that accumulate over time, that's what can lead to a tumor. All right? The P53 gene is designed to find mutations and fix them. But as time goes on, as you get older, this P53 gene doesn't function as well. Now, what the P53 and apoptosis have in common is if the P53 gene finds too many mutations that it can't fix, it just tells that cell to go through apoptosis. And remember, apoptosis, PCD, programmed cell death. All right? Now, it has been proven in numerous spots that tobacco use will directly damage the P53 gene. And it's this damage to this gene that will lead to the lung cancers and other cancers that are related to tobacco smoke. So one of the best ways that you can avoid getting cancer is do not smoke or dip or chew tobacco. All right. Now you see this word right here, carcinogen? A carcinogen is anything that causes cancer. And it's related to a word called mutagen. A mutagen is anything that causes a mutation. So this is a particular mutation that leads to cancer. That's why it uses the word carcinogen. All right? So just to review, uncontrolled cell growth is called cancer. A mass of cancer cells is called a tumor. Tumor cells have the ability to live forever because their telomeres do not get shortened, and therefore the Hayflick limit does not apply to them. The P53 gene, which is known as the guardian of the genome, acts as a major spell checker during the S phase. It will try to fix the mistakes in the DNA. Mistakes are called mutations. If it cannot find a way to fix these mistakes, it triggers the cell to go through apoptosis, which is that programmed cell death that was talked about in podcast number 9. And tobacco smoke, which is a major carcinogen, will damage the P53 in numerous places, and that will almost inevitably lead to cancer. Remember, when it comes to smoking, it's a question of when, not if, you'll get cancer. One more podcast to go in this chapter, and make sure you check that one out. That one will be on stem cells, one of the cutting areas of modern biology.